Hey everybody! Today's practice problem comes from Economics, 4th edition, by R. Glenn Hubbard and Anthony Patrick O'Brien. Today we're going to be doing Chapter 4, problem number 3.11. The problem begins with the following introduction. It says, to drive a taxi legally in New York City, you must have a medallion issued by the city government. City officials have issued only 13,200 medallions. Let's assume that this puts an absolute limit on the number of taxi rides that can be supplied in New York City on any day because no one breaks the law by driving a taxi without a medallion. Let's also assume that each taxi can provide 6 trips per day. In that case, the supply of taxi rides is fixed at 79,200, or 6 rides per taxi times 13,200 taxis. So we show this in the following graph with a vertical line at this quantity, and then we're given a picture that looks like something here. And it says, assume that there are no government controls on the prices the drivers can charge for rides. So let's think about what we have here. So I recreated the diagram in the textbook with slightly different labeling, but the idea is the same, that we have what would be just our free market supply curve like this. We have a consumer's demand curve like this, and then just market quantity in number of taxi rides and market price in dollars per taxi ride. And what we'll see here is that we don't have a price control as we typically talk about. We don't have a price floor or a price ceiling. What we have instead is what I called a quantity ceiling, that we actually set a legal maximum on the quantity that could be supplied of this good in this market. Here, what you'll see in the textbook is it says that this is just supply without the medallion requirement, and then this kinked line here is supply with the medallion requirement. But the idea is the same, and then we've just labeled some areas that we're going to come back to and refer to later. And you'll notice that the number mentioned that was the 6 rides per taxi times 13,200 taxis is just this quantity here. So you see how everything lines up. And then part A of the question just says, what would the equilibrium price and quantity be in this market if there were no medallion requirement? Well, this is really easy, right? That this is just the intersection of the original supply curve and the consumer's demand curve. So we would look here and we would say, in a free market, I'll just label this free market, so we write everything down so we have something to come back to. So in this free market, our equilibrium price is going to be $20, so I can just say P star equals 20, and our equilibrium quantity is just going to be 100,000, so we'll say Q star equals 100,000. So this is basically our baseline comparison scenario where we're then going to say, well, let's compare the situation with the medallion requirement to the situation where we would have a free competitive market. Part B of the question asks, what will price and quantity be with the medallion requirement? So then we can look over here and we can notice that because we have a situation where the quantity ceiling was in fact lower than the free market equilibrium quantity, we can see that this quantity ceiling is in fact going to be binding, or it's going to have an effect on the market. Whereas if instead the taxi cab commission said, oh, well, guess what, we'll issue enough medallions so that taxi drivers can provide 150,000 taxi rides, they'd be setting a quantity ceiling that would be all the way over here. And what would end up happening is the market would realize, hey, we don't really want to supply 150,000 taxi rides anyway, so not all the medallions are going to get purchased, and we would actually see this regular market outcome here. But instead, we see that this quantity ceiling is going to be binding, so then it's not surprising that in this regulated market, the equilibrium quantity or the steady state quantity of taxi rides is in fact the level of this quantity ceiling. So we could come over here and we could say, with our medallions, at least we know that our Q star is going to be $79,200. And then the next question is to figure out what our equilibrium price is going to be. So there are a number of ways to think about this, and it's both pretty simple to figure this out, but also slightly less simple than it might seem. Because what you'll notice is at a quantity of 79,200, we have a marginal cost of production of 10 for the suppliers and a willingness to pay of 30 for the customers. You say, well, wait a minute. There are a whole range of prices between 10 and 30 that would technically make both parties better off. So which one is actually going to happen in this market? That's what we need to figure out, right? And what's actually going to happen, think about what the market dynamics here look like. That you have all these independent, individual consumers that don't have a lot of market power, right? That they're basically, any one of them is just taking the price of taxi rides as given. If I take more taxis than usual, I'm not actually pushing up the price of taxi rides, right? So they're taking the price as given. And then the producers of taxi rides really don't have any incentive to lower their price below the maximum that the market will bear. Because usually what we see in a competitive market when we have firms competing with one another is that they're lowering their price so that they can actually sell more of their stuff. But what we said here, and this is actually an important part of this problem, is that each taxi driver can only provide 6 rides per day. So if the market would bear this price of $30, we think about, well, does any individual producer have an incentive to charge, say, $29? Well, if he charged $29, he would still only be providing 6 taxi rides per day. And even at this price of $30, he was providing 6 taxi rides a day. So there's no incentive for him to actually lower his price. So what we can see is that the price that's going to prevail in this particular market, because there's not an incentive or an ability to increase quantity by lowering price, is that we're going to look at this quantity and end up at the highest price that the market's going to bear, which is this $30 here. This may not always be the case, that we might have some structures, especially if we stop specifically looking at our supply and demand diagram, where producers and consumers have some market power, in which case the price would be the result of some negotiation between those parties. But in this case, we see that the incentives aren't there to bid the price down and to create a shortage. So in fact, we're going to see the price remain here. That's not entirely surprising, because if we were to think about what our supply curve looks like under this medallion system, it's this hockey stick looking thing here, where at prices below 10, we're still on our original supply curve because the medallion hasn't become relevant yet. But then we get this vertical line where increases in price can't actually provide more taxi rides once we hit that quantity ceiling. So what we're really seeing is that the equilibrium price really is at the intersection of the new supply curve and the demand curve, which is right here. Now, the next parts of the problem ask us to analyze consumer surplus, producer surplus, etc., both in the free market and in the market under this quantity ceiling or this medallion system. So to do that, rather than literally going one piece at a time in the order that the questions were given, it's generally helpful to set up a welfare table so that we can organize all of our information. And in this particular instance, we want to think about what parties we need to include in our total surplus. We have consumers and producers, as usual. And when we enter this regulation into account, we say, well, there might be some indirect revenue. We weren't given that information, in that the city or the taxi cab commission or whatever might be selling the medallions, so there might actually be some government revenue. But there's not direct government revenue here in the way that there is with a tax, and we can't really see how much the medallions are getting sold for, and so on and so forth. In reality, in New York, in case you're curious, the medallions do get sold for astronomically high sums of money. So it is relevant, we just don't have that information here. So let's just consider the direct effects in the market. We can say, well, here, it just seems like we have consumers and producers. So we can do our welfare table. We can have a 4x4 grid because we have consumer surplus, producer surplus, total surplus, and then we have our free market, our quantity ceiling, and then our change. And of course, one row and column for our labels. So we could do something like this here. We could say CS for consumer surplus, PS for producer surplus, and then TS for total surplus. Sometimes we call this social surplus, SS. And we could say, well, free market, quantity ceiling, and change. So we can go through and do this, and the problem actually asks us to do this both in terms of the labels that we have here, and also in terms of numbers, which gives one calculation that we'll get to in a second. But let's do this first just with our letters, okay? So this is pretty straightforward because we have very simple rules for how to find consumer surplus and producer surplus. So we say the consumer surplus is everything above the price that the consumer pays. So with the quantity ceiling, it's going to be this price. In the free market, it's this price. Let's just do free market first. So we say it's everything above the relevant price to the consumer, below the demand curve, to the left of the quantity being transacted. That's just going to leave us with areas A, B, and C. So we can just put A plus B plus C here. For producers, the rules are everything below the relevant price to the producer, which in a free market is still this $20, above the supply curve, and to the left of the quantity being transacted. So that's just going to give producers D plus E plus F for a total surplus of A plus B plus C plus D plus E plus F. And that's not surprising. That's just what we've seen a number of times before. So then this gets more interesting. Let's do the same thing with the quantity ceiling in place. So again, same rules. Consumer surplus is now everything above the relevant price for the consumer of $30, below the demand curve, to the left of the quantity being transacted, which is now this $79,200. So now consumers just get A. Producers, again, everything below the relevant price for the producer, which is 30 still, above the supply curve, and to the left of the quantity being transacted. So you want to be careful here. We can't get surplus on units that aren't actually bought and sold, so you want to make sure that you're actually stopping here. So producers get B, D, and F, and we can put B plus D plus F here like this for a total surplus of A plus B plus D plus F. The problem also asks us to give numbers for consumer surplus, producer surplus, and total surplus in each of these cases. And that's pretty easy to do because we can see that we just get a bunch of triangles and rectangles and things like that. So I'm going to level with you here. This is the second time I've done this problem for you. The first time I got through it, something didn't make sense and I had to erase all of it and start over. So the first time that I tried to do this, and I'm explaining to you what happened because I think it's actually helpful for you to know. So the first time I went through and just said, okay, A plus B plus C is a triangle, so I'll just do 1/2 base times height, so just 1/2 times 100,000 times 20. I got a number, and I did the same thing for producer surplus. And then I came back to calculate these individual things. And I actually got a number here where the total surplus was higher under the quantity ceiling than under the free market. I'm like, wait, I know enough about economics to know that that's not how it's supposed to work. Something's up. And I stared at the numbers, went back to my calculator, number of times to say what is going on. And what's actually going on, and if you were to think about these numbers, you would realize that this is the case, that what we drew here as a straight line and a straight line is actually not to scale. So, and if you were to think about that, that makes sense because the ratio of 10 to 79,200 is not the same as the ratio of 20 to 100,000. So we don't actually have, given these numbers, straight lines. So if we tried to calculate this as one big triangle, we would actually get something different from what the true areas would be. So you want to be careful about that. And one thing, the advice that I would give in general is, hey, if you're given numbers and asked to calculate things like this, if you're calculating something as a big triangle, just do a sanity check to make sure that things that are drawn as lines are actually lines, because sometimes they're not, apparently. So what we can do here instead, all is not lost. We can go through and we can calculate the areas of each of these guys individually, and then we can just add them up where relevant. Seems easy enough, and that actually seems like a safer approach, given that if we do that, we don't have this problem. It becomes irrelevant whether these guys are actually straight lines. Okay. So we can proceed by just calculating the areas individually of A, B, C, D, E, and F, and then adding them together as necessary. So let's do this. We can just say A, B, C, D, E, and F. And we'll write down the formulas for each of them, and then we can just use the calculator to figure out what they are numerically. So here we have A is the area of this triangle here. Area of a triangle, just 1/2 base times height. So we're just going to have 1/2 times a base of 79,200 times a height of 10. So 1/2 times 79,200 times 10. Our area B is a rectangle, so we just have the area of a rectangle as length times width. So we have a width of 79,200 and a length or a height, however you want to think about that, of 10. So we would just get here 79,200 times 10. We can go a little out of order, and we can notice that area D is also a rectangle with dimensions similar to those of B. So again, we just get 79,200 as our width times a height of 10. So I can stick here 79,200 times 10. We have F, which has a base of 79,200 and a height of 10, but it's a triangle, so its area is 1/2 times 79,200 times 10. And then notice C and E required one small additional calculation. That we say C is a triangle, so its area is 1/2 times a base of, that's the difference between 100,000 and 79,200, which, by the way, you can just find by subtracting. And if you subtract, you get 20,800. So this is then just going to be 1/2 times 20,800 times a height of 10. Similarly, triangle E is going to be 1/2 times a base of 20,800 times a height of 10. So we can just put 1/2 times 20,800 times 10 here. And then our next step is to just get out our calculator to figure out what these are numerically. So I just go here, say 0.5 times 79,200 times 10. This is going to be 396,000. And we'll notice that if this is 396,000, this is also 396,000 because it's the same calculation. We can see that area B multiplying by 10 is pretty easy, right? So this is just going to be 792,000. Similarly, D is going to be 792,000. And then area C is just 1/2 times 20,800 times 10, which gives 104,000. And we'll notice the area E is just that same calculation, so this also has to be 104,000. So we're making progress because now we have the individual area for each of these, and we can go through then and just add them up to find out what's actually happening with our consumer surplus and producer surplus. So given these numbers, we now have that area A plus B plus C is 396,000 plus 792,000 plus 104,000, which is 1,292,000. So far, so good. Similarly, we can see that producer surplus is 792,000 plus 104,000 plus 396,000, or 1,292,000. And if we added these together, we get a total surplus of, drumroll please, 2,584,000. Now, one thing you'll notice here is that consumer and producer surplus were the same. That happened basically by coincidence. So generally, consumer and producer surplus could be different. They could be the same. There's no rule about how they're actually distributed or how they relate to one another. And in fact, the relation between consumer surplus and producer surplus is determined by the relative elasticity of demand and of supply. So the reason here that we're getting numbers that are the same is because we have curves that have basically the same elasticity. So that won't always be true. Don't make assumptions. But it happens to be true in this case. And then we can do this under the quantity ceiling, and we can see, well, area A is just 396,000. Areas B, D, and F are 792,000 plus 792,000 plus 396,000, or 1,980,000. So producers do really well under this system, for a total of 2,376,000. So one thing we notice here now, as we expected, our total surplus is lower under our quantity ceiling than in our free market, because we said the government interventions in otherwise well-functioning competitive markets are going to lower total surplus. So if you get an outcome where you don't see that, you want to at least think, is there a good reason why I don't see what I was expecting? And we could also calculate the changes, and we could do that either using the letters or using the numbers, right? So consumers are worse off by areas B and C, because that's what they're losing under the quantity ceiling. Producers, it's a little bit confusing because we see a D, we see an F here and an F here, we see a D here and a D here. So it's really this B and this E that we want to contend with. So what we see is under the quantity ceiling, producers are gaining B, but they're losing E. Okay, so make sure you do that the right way. And then total surplus here is going down by the amount C plus E, because we had C and E here, but we don't here. And we can think about what these areas mean. We could see that, for example, area B was a transfer from consumers to producers because of this quantity ceiling, because we see that it's being lost by consumers and gained by producers. And we could also see that this area C and E is what goes into essentially our economic black hole, right? That we're not capturing this surplus that we used to capture in the free market. So in more technical terms, we could say that our deadweight loss, which is the reduction in total surplus experienced by some sort of market distortion. So that deadweight loss is then just going to be C plus E. And again, we can go through these numbers and we can see, for example, that the change in total surplus for consumers, just plug in the numbers. So consumers are losing $896,000. Producers are gaining $688,000. And overall, we're losing out on $208,000. So we could additionally say here that our deadweight loss is in fact $208,000. And one helpful check that you can do to make sure that you didn't do anything wrong, either numerically or with the letters, is you could notice that the change in total surplus is something that we could calculate directly. So it must be the case that this minus this equals this. But it's also the case that the change in total surplus has to be the change in consumer surplus plus the change in producer surplus. So we could also make sure that this plus this equals this, and that just gives us a nice check on our numbers to make sure that we didn't make any calculation errors. The last part of the problem says, in 2011, the state of New York allowed New York City to sell 1,500 new taxi medallions. Assuming that each of the new taxis can also provide 6 rides per day, what is the new quantity of taxi rides per day? So now what we're doing is we're adding 1,500 times 6 to our allowable quantity, right? So if we were to do this math, we would just say, well, I can figure this out. So 1,500 new medallions, each one of them was providing 6 rides a day. So we've added 9,000 rides to our allowed quantity. So if we add 9,000 to our existing 79,200, we get 88,200, which is somewhere here. Just going to put it sort of in the middle. So this is 88,200. And what then our supply curve would look like, we would say, well, our supply curve would look normal until we hit this quantity. We'll pull this up here. And then we'd start hitting the vertical part here. I'll call this QC2 for quantity ceiling 2. And you can think about the impact that this has on the market by the same reasoning that we did before. That we could then say, oh, look at what's going to happen. The new equilibrium is going to be where this kinked supply curve intersects the demand curve. So the new equilibrium is going to be here, which we notice is at a larger quantity, not surprisingly since the quantity ceiling was increased, but also at a lower price. Because now, in order to actually sell all the rides to hit that quantity ceiling, we can't charge as much as we did before. The last thing that this question asks is it says, on the graph, show the effects of the new medallions on consumer surplus, producer surplus, and deadweight loss, but then it says you don't have to calculate the values. So we can look here and think about what's going on. So under the old quantity regime, consumers just got this area A, right? But under the new quantity regime, because the price was lowered, I put it in here as P star sub QC2 to correspond to the quantity ceiling 2. So now consumers are getting more for a lower price. So their consumer surplus is increasing, and you can see that because the new one is just this triangle here, whereas the old one was just area A. Producer surplus, we can see, used to be this area B, D, and F. So the way to think about their changes is a little bit more complicated because they're able to sell more taxi rides, but they're actually doing so at a lower price than they were before. So you have two competing effects here. One being that producer surplus is now extended further to the right. Right now we're getting producer surplus on units up to 88,200, but we're getting them at a lower price than we did before. So we have a bit of a trade-off going on there. So it's a little bit of an ambiguous effect on producer surplus. But most importantly, we can think about what happens to deadweight loss. So to do that, it's helpful to notice that deadweight loss was just our area C plus E. So we could come here and we could notice that it's just this triangle that's between the free market quantity and the quantity ceiling, and then bounded by the supply and demand curves, right? And that makes sense because this deadweight loss represents the loss where there were units in the free market where the consumer valued those units more than it cost them to produce, more than it cost producers to produce, of course. So these were transactions that could have been profitable that were actually prevented because of the quantity ceiling. So we get deadweight loss of this area here. So if we were to think in the same way about where deadweight loss would be with the new quantity ceiling, we would see that it's just going to be the amount of this smaller triangle here. So what we can see is when we put consumers and producers together, their total surplus must be higher under the larger, the new quantity ceiling than under the old one, and it must be the case that deadweight loss actually decreased. And that's not surprising because this new quantity ceiling, this larger quantity ceiling, is bringing us closer to the outcome that we knew to be optimal from a total surplus perspective.